Okay, so in continuation, we have here example number 3. Consider a voltaic cell in which the following reaction takes place. So we are given here the reaction, and we are to calculate the cell voltage given that the concentration of Au3+, that's gold 3 ion, which is 0.25 molars, the hydrogen ion concentration 1.25 molars, and the concentration of the hydrogen peroxide solution 1.5 molars. So the first thing that we are going to do, just like what we did in the previous example, is to determine which of the species here, which of the elements undergoes oxidation or reduction. So this is positive 1, negative 1, positive 1, 0, positive 3, and positive 1 and negative 2. So we can see here that oxygen, there is a decrease, so meaning it undergoes reduction, and gold, there is an increase, so it undergoes oxidation. So we are going to find the half reactions from the table. So looking at the table, we can see that gold here, so make sure that you look at the oxidation number properly. So it's Au3+, and the standard reduction voltage is 1.498, and for hydrogen peroxide, it's 1.763. But since gold undergoes oxidation, so gibaliktad siya, so nahimong negative 1.498, and as is ang sa hydrogen peroxide. So adding the two, so we get the standard cell voltage, which we're going to use in the Nernst equation, and we have to make the number of electrons equal in both half equations. So this is 3 and 2, so actually we multiply this by 2, and we multiply this by 3. So muna siya ang atong equation, which is, you have to make sure nga equal siya, pareha siya sa given nga equation, and this gives us that n is equal to 6. So our Q would be product over reactant. So in the product, we include the concentration of the gold 3 ion, and then we raise it to the power of 2 because of the coefficient. We do not include the water, so we just write 1 imaginary for water because that's liquid. And then for gold in the reactant, we do not include that because that's a solid. And so we include the hydrogen ion concentration, that's raised to the power of 6, and for the hydrogen peroxide, that's raised to the power of 3. So we substitute, so standard cell voltage is 0.265, and then N is 6, and then the concentration of gold is 3 plus, 0.25, we raise it to the power of 2, and then the concentration of hydrogen is 1.25 molars, we raise it to the power of 6, and for hydrogen peroxide is 1.5 raised to the power of 3. So please get your calculators and please solve. Try to check if the answer is correct, or if you will be able to get the correct answer. So make sure that you include the parentheses. You make use of the grouping symbols properly so that you'll be able to get the correct answer. So if we round this off to the 4th decimal place, this is 0.2878 molars. So that would be the cell voltage given the different concentrations of the species. Example number 4. Consider a voltaic cell in which the given reaction takes place. So this is the overall cell reaction, and we are given the concentration of the species involved. So to determine which undergoes oxidation and reduction, so we assign oxidation numbers to each of the elements here. And we can see that for oxygen, there is a decrease in the oxidation number, so it undergoes reduction. And for nitrogen, there is an increase in the oxidation number, meaning it undergoes oxidation. So we write the half reactions. We can just actually base it from the table. So for nitrogen, NO and O3, so this is NO, that's a gas, and it undergoes oxidation. So we will look for the table here. So this is the table that we are going to use. So these are the values that we are going to use. This is for NO and this is for oxygen. So for NO, ato ra siya baliktaron, NOHO to H2O. Okay. So plus 2H2O, that's a liquid, and then producing nitrate plus a hydrogen ion plus 3 electrons. And the standard oxidation voltage is, so baliktaron nato siya, mahimo siyang negative 0.964 volts. And then for oxygen, so we're simply going to copy this. So this is a gas. And then it will produce 2 moles of water. That's liquid. And the standard reduction voltage is 1.229. And then we're going to add the 2 to get the standard cell voltage. So it's 1.229 minus 0.964. Let me check that again if it's 0.964. Okay. And we're able to get 0.265 volts. So this is what we are going to need this for the Nernst equation. And then we have to make the number of electrons equal. So we're going to multiply the first equation by 4 and the second equation by 3 to get the LCM nga 12. And again, we're going to need this in the Nernst equation. So let's check if we add the 2 equations, will we be able to get the given equation. So si NO, ang iyan ang coefficient kay 4, that's a gas, plus oxygen 3, iyang coefficient, and then, so for water, there's water here and there's also water on the left. But water here multiplied by 4, that's 8, and water on the right multiplied by 3 is 6. So difference of 2 and greater ang nasa left. So mahabilin si water duha ka buok sa left side, sa reactant side. And then we have 4 NO3 negative AQ plus, and then we have hydrogen. So this is 4 times 4 is 16, and then this is 4 times 3 is 12. So there's a difference of 4. So 4 H plus AQ. And we can see nga pareha siya sa given nga equation. Okay, so using Nernst equation, so we can substitute directly. So we're looking for E, and then the standard cell voltage is 0.265 volts minus 0.0257 volts divided by N, which is 12, and then Ln of ang nasa product kay. So ang Q ani niya would be concentration ni NO3 negative raised to the power of 4 times concentration sa hydrogen raised to the power of 4 divided by, so walay labot ang water, so pressure ni nitrogen monoxide raised to the power of 4, pressure ni oxygen raised to the power of 3. So we already have NO3, which is here. We have the pressure of nitrogen monoxide para ani. We have the pressure of oxygen para ani, but we do not have the concentration of hydrogen. But we have pH. Now, pH class, pH is equal to the negative log of the hydrogen ion concentration. And remember nga kung wala ni number diri, understood that the base is 10, And if we are to change that to exponential form, then the hydrogen ion concentration therefore is equal to 10 to the negative pH, or you can write negative 10 to the power of pH, either way. So we can use this pH here to solve for the hydrogen ion concentration. So ang concentration, so this is 0.75, so this is for the nitrate ion raised to the power of 4, and then for hydrogen, that's 10 to the negative 2.85, and we also raise that to the power of 4, and then divided by pressure of the nitrogen monoxide, which is 0.993 atmosphere, and we raise it to the power of 4, and then pressure of oxygen, which is 0.515 raised to the power of 3. And then just input everything in your calculator, but you have to make sure, as I said a while ago, that you use the grouping symbols correctly para dili masayo. So make sure nga sakto ang mga coefficients, sakto ang mga exponents. So let's try to see if we'll be able to get the same answer. Use your calculators to solve. And the correct answer, the cell voltage is, if you round it off to the 4th decimal place, you will get 0.3194 volts. This is the cell voltage given the different concentrations.